So I have been at Uber for around 4+ years now, working on the Presto system there. So Presto has a very big footprint at Uber. We currently run Presto across 4 regions, 2 in the cloud, 2 in the prem, around 50+ clusters and around 16,000 hosts and a lot of cores. So my colleagues, they went over a bunch of presentation about the Presto, how it's distributed across the regions, and also I won't go into those details, but I'll talk about some aspects of the Presto resource management, which actually were very important for us. So Presto at Uber is used for a bunch of use cases. So of course, there is the ad hoc analytics, which is one big group of clusters are used for interactive analytics. But then we have a bunch of, the rest is all batch use cases. We have Presto used for data quality tests. Actually, a lot of tests run on Presto, most of them, because like they are used for quickly verifying that the data is consistent across the various regions. Presto is used for experimentation, for A/B testing, for dashboarding, for ETL. It's used a lot by operations teams to kind of figure out operational issues. And then it's used a lot by data services at Uber. For example, we have like some data services which generate reports for merchants across weekly reports about how the business is doing. We have some services which generate some pricing and payment support for the riders and the drivers, and bunch of other services also. So basically at Uber, the system that we use for driving Presto, the front end for Presto, is called Query Runner. And this is kind of the gateway for all the workload that comes into Presto at Uber. So in this talk, basically, I'll be talking about a little bit about the queue management. So to motivate the talk, I'll just start with the last 7 days, what was the batch queue at Uber, and this is just the last week's queue stats. So the queue buildup happens a lot, and the weekends are generally kind of less crowded, but the early weekdays we have like a lot of queries which build up. So queue management, queue SLA becomes very important. So initially, when the system was started, the Query Runner, it has many roles. So it's not only the front end for Presto, but it's also the front end for a lot of other data technologies like Spark, Neutrino. Neutrino is basically Pinot under Presto, and then of course MySQL and all that. So the Query Runner provides an API as an API server for the clients to submit their queries. It orchestrates the life cycle of the queries. But it also maintains, very importantly, the fairness of resource consumption by maintaining the queues in a FIFO order and controlling the query dispatch rate per consumer per queue. So given the amount of resources that we have, Presto resources, and given the amount of queries that we get, it's very important to maintain the fairness, because the clusters that we have at Uber, the 50+ clusters, most of them are shared clusters. They are not dedicated for a particular team or an org. So for us, it's important to make sure that one user or one group of users do not end up kind of overshadowing or using up most of the resources. So of course, like once you have a queue, then you run into a problem that you will have, you don't want to have the head of the line blocking in the queue. So when you have different resources which are fronted by the same queue, then it becomes kind of inefficient, because like one query which is sitting at the head of the queue, which wants to go to one group of clusters, can end up blocking other queries behind it, even though the other queries might want to go to some different clusters. So of course, like the simple solution for this was to have a separate set of queues matching each of the cluster sets. So we have like a separate queue for interactive, separate queue for high tier, and a separate queue for low tier. So this was fine, but what we saw was that this was kind of not becoming efficient as the number of cluster groups increased. So while those initially it was sufficient, but later we started to have a lot more cluster groups. So in addition to the high tier, low tier, and interactive, we had one express cluster group, which was a cluster group for short queries. We had some Presto and Spark group of queries. We had some private cluster and a cloud cluster. The static queue configuration that Query Runner had was no longer sufficient to make queuing decisions for these group of queries. And also, like the queries that come to Presto, they come with a user and a consumer. So consumer, you can think of it as kind of a team level entity, and a user is an individual user. So then we had to add a feedback loop from Presto, because Query Runner is kind of so far separated from Presto. But given the number of cluster groups that we had, and then going into the cloud, there are a lot more cluster groups now. So we had to kind of create a feedback loop from Presto back to Query Runner, where Query Runner has to ask Presto as to which queue the query needs to go to. And this is kind of not something that Query Runner itself can decide. Because maybe it can decide between interactive and the high tier, interactive and batch, because interactive comes from the SQL editor and batch comes from the data services. But Presto has to decide whether the query is an express query and all. So the Query Runner needs to kind of get that hint from Presto as to which queue the query needs to go to. So what we ended up designing, and this was done by the BI team, which is a partner team of Presto, is to build a queuing system where when the query comes, it is first kind of sent to Presto service, which is called Preon, to validate the query and get the queue and the cluster information as to which cluster group this query is going to go to. And based on that cluster group, then internally, Query Runner creates a set of conceptual queues. And then it puts the queries in those particular queues. Furthermore, like within the queue, we differentiate between the user, between the consumer and the user. So in the query, in one queue, the queries will be, you can think of it as a sub-queuing within the main queue based on the consumer, which is like Piper, UDQ, and then furthermore based on the user under the same consumer. So with this, the system allows, the Query Runner allows us to define limits in terms of the number of concurrent queries which a consumer can run within a particular queue, or a user can run within a particular queue. So the way we implement is that we have a Redis counter, which we used to keep track of the executions which are submitted to query runner. And then the execution UIDs are kind of hashed to generate the query count, which is kind of an implementation optimization. And then the other thing that we do is that, as I was saying, that we also have a user level limit under the consumer. But this limit, we also make it across all consumers so that we don't let the users game the system by creating multiple consumers just to get over the user level limit. So doesn't matter which consumers the queries will come through. The queries will still get gated under a user level limit. So we rolled these optimization across about like a year ago, when the system transitioned from having kind of just the 3 main queues that I was talking about initially to having a more finer grained set of queues. So in this graph, we showed that what happened is that we had the system working initially, and then we added a set of Presto Express clusters. So this is important because what we thought is that we just added a set of Express clusters, and then the Express queries will go to those Express clusters, and then they will just run fast and quick. But we actually didn't see the benefits that we were expecting to get, and this was because even though the clusters were separate, but the queue was the same. So the Express query was still getting blocked behind the non-Express query in the queue. So even though the clusters were rolled out, until we rolled out the queue level changes, we didn't see the full benefit of the queuing SLA improvement. So we saw a lot of benefit, at least for the short queries where the SLAs went down a lot. And going forward, actually, this is kind of becoming a big problem for us, because given the number of cluster groups that we have to support, it's kind of more than 15. We have to support a bunch of queues. So we are looking for something which is a more scalable solution, which is more kind of in the Presto kind of doing things. So we kind of looking at how we can use something like a resource group to kind of do the resource management, because the basic problem that we have is resource management. And right now we are just kind of trying to implement concurrency control as to the number of running queries that a user can have. But we also want to have something like a CPU level limit as to how much CPU the user can burn in a unit of time. So Presto has the concept of a resource group at a cluster level, but we run a lot of clusters across different regions. So what we need is something kind of a meta resource manager, a meta resource group manager which can run at a federation of Presto clusters. So we have started looking at whether we can take the resource group functionality out of the Presto coordinator and implement it at a meta level, such as a Presto router. But we kind of still are investigating it, but looking for feedback from the community as to if there are some existing good solutions out there already. So that was pretty much my presentation. So any questions, feel free.